Here's something that shouldn't make sense. The Sun is 93 million miles away. The Moon, just 239,000. One is 400 times larger than the other. And yet, from where we stand, they look exactly the same size in the sky. That is not supposed to happen. No other planet in our solar system gets a perfect solar eclipse. No other moon sits at a distance that stabilizes its planet's tilt for billions of years. And no other planet orbits its star at a distance where water stays liquid, not frozen, not boiled away, for the entire history of life. The distances between Earth, Sun, and Moon are not random. They are so unlikely that, when you look at the numbers, you start to wonder if we're living inside a cosmic fluke, or something even stranger. Our story starts with the Sun, not just any star, a G-type main sequence star, stable enough to burn for 10 billion years without ripping itself apart. Around every star like this, there's a narrow band where a planet can hold liquid water on its surface. Astronomers call it the habitable zone, but honestly, Goldilocks zone says it better, not too hot, not too cold. Earth sits at 93 million miles, right in the middle of that band. But here's what's wild. The habitable zone around our Sun is only about 85 to 110 million miles wide. That sounds like a lot, until you realize Earth could drift just 5% closer and our oceans would evaporate into a runaway greenhouse, like Venus. 5% farther and carbon dioxide freezes out of the atmosphere, locking the planet in permanent ice. 5%. That is the margin between a living world and a dead one. Now, distance alone isn't everything. Venus is technically near the inner edge of the zone, and it's a scorching hellscape. Earth has an atmosphere and a magnetic field that keep conditions stable. But without that 93 million mile starting point, none of that would matter. The distance sets the stage. Now let's talk about the Moon. Most people know it creates tides, but that's just the headline. The real story is much bigger, and it has to do with why Earth can have seasons without swinging into chaos. Earth spins at a 23.5-degree angle. That tilt gives us summer, winter, spring, fall. It's gentle, predictable, and that predictability exists because the Moon's gravity acts like a stabilizer, a gravitational anchor that keeps Earth from wobbling out of control. Without the Moon, or if it were much farther away, Earth's tilt would drift chaotically over millions of years. 0 degrees one era, no seasons, frozen poles spreading toward the equator. Then 60 degrees the next, the poles facing the Sun directly, boiling oceans, collapsing ecosystems. Life as we know it cannot survive that kind of instability, but 239,000 miles turns out to be the sweet spot for another reason: tides. The Moon's gravity pulls on Earth's oceans, creating a rhythm of rise and fall that shaped the earliest life. Scientists now believe that tidal pools, those pockets of seawater trapped and warmed by the Sun between high and low tide, were the nursery where simple chemistry became biology, where the first self-replicating molecules got concentrated enough to start the chain reaction that leads to us. And now we arrive at the strangest part of this whole arrangement. The Sun is about 400 times wider than the Moon. It is also about 400 times farther away. That ratio, that precise, almost impossible ratio, means they appear exactly the same size in our sky, which means we get total solar eclipses. The Moon slides perfectly over the Sun, revealing the corona, the Sun's outer atmosphere, in a way that no other planetary system we've ever observed can replicate. That coincidence has done more than create beautiful moments. Ancient civilizations used eclipses to track time and build calendars. In 1919, a total solar eclipse proved Einstein's theory of general relativity, the bending of starlight around the Sun's gravity. The Moon's perfect fit against the Sun literally confirmed that space-time curves. You don't get that on Mars. You don't get it anywhere else. It only works here, because of distances that have no business being this precise. So here's where we land. Earth sits at 93 million miles from a stable star, inside a narrow habitable zone where water stays liquid. The Moon orbits at 239,000 miles, close enough to stabilize our tilt, far enough to avoid catastrophic tides. And by sheer coincidence, or something we don't yet understand, they appear the same size in the sky, giving us eclipses that have advanced science, tracked time, and reminded every civilization that has ever lived that we are part of something bigger. Are these distances random? Maybe. The universe is vast, with billions of galaxies and trillions of planets, and somewhere, by chance, the numbers line up. We could just be the one place where they did. But the more we learn about how finely tuned these distances are, the harder it becomes to look at Earth and see anything other than the closest thing to a miracle we will ever know. If you want to explore more of these cosmic coincidences, the ones that make you stop and think, subscribe to Akin's Learning Center. Learning must go on.